European crop farms face shrinking work windows, variable terrain, and fuel costs that directly impact profitability. The tractors they choose aren't just based on horsepower, they're also about hectares covered per day, fuel consumed, and uptime during critical seasons. Here are 12 tractors commonly found on high-output European operations, selected because they solve specific production problems under real-world constraints. Central European crop farms operate under a specific set of constraints: rolling terrain, variable soil moisture, and narrow seasonal windows where every hour of workable field time matters. In these conditions, outright horsepower is less important than how efficiently power is delivered to the ground across long working days. The Steyr Terrace CVT sits in the 300 to 313 horsepower class, positioning it as a primary tractor on medium to large European crop farms. It uses a 6-cylinder Stage 5 engine paired with Steyr's continuously variable transmission, designed to keep the engine operating in efficient load bands instead of chasing peak RPM. In practical field work, this matters most during operations like drilling, high-speed seeding, or shallow cultivation, where consistent forward speed and low fuel consumption per hectare outweigh maximum draft force. On appropriately sized implements, for example 6-meter drills or cultivators, operators report roughly 6 to 9 hectares per hour, depending on soil conditions, working depth, and field layout. These figures assume uninterrupted blocks and favorable traction, not marginal conditions. One of the Terrace CVT's strengths is transport efficiency. The transmission allows 50 kilometers per hour road speed at relatively low engine RPM, reducing fuel consumption and operator fatigue during frequent field-to-field moves common in Central Europe. This is particularly relevant for farms operating multiple parcels spread across public roads, where transport time can significantly affect daily output. Rather than maximizing raw power, the Terrace focuses on controllability and efficiency. CVT response can be tuned to the task, allowing smoother acceleration, precise speed control during headland turns, and reduced wheel slip under variable traction. Combined with cab and front axle suspension, this supports long working days without excessive operator fatigue, a factor that directly affects real-world productivity during peak seasons. Efficiency matters in field operations, but some farms face a different constraint entirely. Remote farms in Northern and Eastern Europe face a constraint that doesn't show up in brochures: distance from dealer support. When the nearest service center is 100+ kilometers away and you're in the middle of spring drilling, downtime has consequences that extend well beyond a single day's lost work. Valtra's approach to the S294 reflects Finnish engineering priorities: extended service intervals, modular component design, and build quality focused on reducing unplanned maintenance. The S294 uses a 6-cylinder, 8.4-liter AGCO power engine, rated at approximately 295 horsepower, paired with a variable transmission offering 0.03 to 50 kilometers per hour range. Rear lift capacity is around 10,000+ kilograms, sufficient for heavier implements common in Scandinavian and Baltic farming systems. What distinguishes this tractor in actual use is not peak power, but maintenance intervals stretching to 600 hours and a design philosophy that prioritizes component access and replacement speed. The 630-liter fuel tank reduces refueling frequency during critical operations, a practical advantage when working large parcels far from infrastructure. In field operations, the S294 handles approximately 6 to 8 hectares per hour on power harrows or similar cultivation equipment under favorable conditions. On transport work, it can move grain trailers in the 200+ ton per day range, assuming efficient logistics and suitable road access. The pneumatic cab suspension supports extended operator hours without excessive fatigue, relevant during the compressed work windows typical in Nordic climates. Uptime is valuable on remote farms, but mixed operations face a different problem of needing one machine that can handle multiple roles without compromise. Mixed farming operations, combining arable work, livestock, and seasonal contracting, face a problem. They need one primary tractor that handles diverse tasks without performance compromises. Specialization is expensive when you're working 200 to 300 hectares with variable crop types and supplementary livestock enterprises. Case IH's Puma 240 addresses this by operating in what might be called the versatile middle. Enough power for primary field operations, but not so specialized that it becomes inefficient on lighter tasks. The 6.7-liter FPT-NEF engine delivers 240 rated horsepower with a boost function reaching 270 horsepower when needed. Torque peaks at 1,160 Newton-meters between 1,400 to 1,600 revolutions per minute, supporting consistent pull across varying loads. Hydraulic flow ranges from 178 to 214 liters per minute depending on configuration, sufficient for modern drills, cultivators, and loader work without requiring separate dedicated machines. On cultivation work, operators can expect roughly 4 to 6 hectares per hour with 5 to 6 meter tillage at approximately 10 kilometers per hour, assuming consistent soil conditions and appropriate working depth. On haulage, the tractor handles 150 to 200 tons daily at 40 to 50 kilometers per hour road speeds, suitable for grain cart work or silage transport. The high ESCR2 emission system maintains power delivery while managing fuel consumption, critical for operations where cost per hour matters as much as output per hour. Transmission options include power drive or CVX drive, allowing farms to balance initial cost against operational preferences. Versatility solves mixed farm challenges, but large-scale arable operations face a different priority of minimizing fuel cost across hundreds of hectares. Large-scale arable operations in Germany and France operate on margins where fuel efficiency isn't a secondary consideration. It's a primary cost driver. When you're covering 800-plus hectares per season, a 5% improvement in liters per hectare translates directly to profitability, especially when diesel prices fluctuate. The Fendt 942 Vario uses a 9.0-liter MAN 6-cylinder engine delivering approximately 415 gross horsepower, transmitted through Fendt's Vario Drive continuously variable transmission. This CVT enables stepless speed control from 0 to 50 kilometers per hour, allowing the operator to maintain optimal engine load regardless of ground speed. Hydraulic capacity reaches 430 liters per minute in combined pump configurations, supporting high-demand implements without flow restrictions. Rear lift capacity approaches 12,654 kilograms, handling wide cultivation and drilling equipment without strain. In field operations on large square parcels typical of German and French arable farms, the 942 Vario can cover approximately 8 to 10 hectares per hour with 8 to 10 meter cultivators or drills at 10 to 12 kilometers per hour, assuming uninterrupted blocks and favorable soil conditions. Over a full working day, this can translate to roughly 80 to 100 hectares under efficient headland management and minimal downtime. The key advantage here is not raw power, but sustained efficiency. The CVT's mechanical efficiency points and Fendt's low specific fuel consumption reduce liters per hectare during extended operations, directly addressing the cost pressure that defines large area arable farming. This efficiency becomes most visible during tight sowing windows, where the ability to finish large areas quickly without excessive fuel consumption determines whether you hit optimal planting dates. If you value real production numbers and engineering trade-offs over marketing claims, subscribe to our channel. We focus on how machines actually perform under field conditions, not what they look like in promotional material. Fuel efficiency helps control operating costs, but some farms face a more immediate constraint of shrinking weather windows that force them to maximize daily area coverage above all else. Climate variability across Europe has compressed work windows. What used to be a predictable 10-day drilling period might now be 3 72-hour windows separated by rain systems. Miss one, and you're planting late with yield penalties accumulating. Klaas designed the Axion 960 around daily area coverage, and the TerraTrack variant addresses a specific constraint: entering fields earlier when soil moisture is marginal. The wheeled Axion 960 delivers up to 445 horsepower with approximately 391 horsepower available at the PTO, using an 8.7-liter FPT engine and CMA-TIC continuously variable transmission. Permissible gross weight reaches roughly 22 tons, with load capacity near 6 tons. With appropriate implement sizing, typically 12-meter cultivators or 9 to 12-meter seeders. The Axion 960 can achieve approximately 10 to 14 hectares per hour at 10 to 12 kilometers per hour on large, uninterrupted blocks. This translates to 100+ hectares per day under optimal conditions with efficient headland turns and minimal transport interruptions. The TerraTrack version adds suspended rubber tracks on the rear axle, increasing ground contact area without exceeding road transport width or weight limits. This isn't about extreme mud performance. It's about gaining access to fields 1 or 2 days earlier when soil is slightly wet, but workable. That earlier access can be the difference between completing drilling within an optimal window or losing significant yield to delayed sowing. Lower ground pressure also reduces slip, improving fuel efficiency per hectare and maintaining consistent working depth across variable soil types. The tracked configuration is particularly relevant on heavier clay soils common in parts of Germany, northern France, and the UK, where soil compaction and trafficability directly limit seasonal output. High daily output matters when weather cooperates, but European infrastructure creates a specific tractor design problem. You need serious field power, but it has to fit through village roads, stone gateways, and weight-restricted bridges built decades before modern agricultural equipment existed. American-style mega-tractors simply don't work logistically. The New Holland T 7.315 HD addresses this by delivering approximately 313 horsepower in a chassis that remains compatible with typical European transport infrastructure. The FPT engine produces maximum torque near 1,282 Newton-meters at 1,400 revolutions per minute, with gross vehicle weight up to roughly 16.8 tons. The continuously variable transmission and advanced front axle suspension maintain traction and operator comfort at road speeds up to 50 kilometers per hour. In field operations, the T 7.315 HD handles 6-meter cultivators or drills and 4-meter deep tine cultivators at 8 to 12 kilometers per hour, covering roughly 5 to 7 hectares per hour depending on implement type and soil conditions. On haulage work, the high permissible weight and available torque allow 40 to 50 kilometers per hour transport of 18 to 20-ton payloads, critical for farms with scattered parcels requiring frequent road movement between fields. Precision land management integration provides factory-installed auto-steer, headland management, and variable rate application capability without complex aftermarket retrofits. This reduces setup time and improves system reliability compared to third-party precision systems. Compact power addresses transport constraints, but some farms need a tractor that genuinely excels across multiple enterprise types without forcing operational trade-offs. Specializing in one high-horsepower flagship tractor and multiple smaller support machines increases both capital cost and operational complexity. The alternative is finding one primary machine that genuinely handles diverse work without performance compromises. The Massey Ferguson 8S.305 sits at the top of the 8S range, using an AGCO Power 7.4-liter 6-cylinder engine delivering approximately 301 to 305 horsepower, with claimed PTO output around 265 HP. This PTO power level supports high-demand PTO-driven equipment like large mowers, tedders, and forage harvesters without excessive power reserve requirements. Closed-center load-sensing hydraulics provide roughly 205 liters per minute of flow, with rear lift capacity rated up to approximately 10,000 kilograms and front linkage around 4,800 kilograms. This combination supports modern wide drills, front-mounted cultivators, and loader work without requiring implement size compromises. In field operations, the 8S.305 handles 6-meter drills at 10 to 12 kilometers per hour, or 4 to 5-meter subsoilers at 7 to 9 kilometers per hour, often serving as the primary field tractor on 150 to 250 hectare operations. On haulage, the combination of 40 to 50 kilometers per hour road speed and approximately 19 to 22 tons operating weight provides stable, efficient grain cart or silage trailer operation. The Dyna VT continuously variable transmission reduces operator input and fatigue, supporting 12-plus-hour working days during peak seasons without significant performance degradation. Stage 5 emissions packaging keeps the bonnet profile compact, improving forward visibility particularly valuable during loader work and maneuvering in confined livestock yards. Mixed farm capability requires balance across tasks, but some operations prioritize a different metric. Progressive mixed and arable farms in Central and Eastern Europe face a persistent pressure of commodity prices fluctuating. Diesel costs rise, labor availability tightens, but output expectations remain constant. In this environment, tractor fuel efficiency isn't a nice-to-have feature, it's a direct profitability factor. The Deutz Fahr 9340 TTV Warrior operates in the 336 horsepower class, using a Deutz engine known specifically for low specific fuel consumption. The TTV continuously variable transmission provides stepless speed control from 0.2 to 60 km per hour, allowing operators to maintain optimal engine load across varying field conditions. Hydraulics deliver up to approximately 210 liters per minute of load-sensing flow, with rear linkage lift capacity in the region of 12,000 kilograms, sufficient for wide combination implements common in Central European tillage systems. At this power level, the 9340 typically operates 5 to 6 meter power harrows or shallow disc cultivators at 10 to 12 kilometers per hour, achieving approximately 5 to 7 hectares per hour under favorable soil and field conditions. During harvest periods, it handles large grain carts or 18 to 20-ton trailers, moving 200-plus tons per day given efficient field-to-storage logistics. The engineering focus here is fuel consumption per hectare rather than peak power. Deutz engines achieve low specific fuel consumption through efficient combustion design and optimized engine mapping. Combined with the TTV's ability to maintain engine speed and efficient load bands, this reduces diesel cost per hectare on fuel-intensive operations like deep cultivation or repeated tillage passes. Reducing fuel consumption per hectare delivers measurable cost savings, but at the highest power levels, one manufacturer has built an entire engineering philosophy around low RPM efficiency. Most tractor engines operate inefficiently because conventional transmission design forces them to run at unnecessarily high RPM. Higher engine speed means increased friction losses, more heat dissipation, and fundamentally higher fuel consumption per unit of work. This is basic thermodynamics, and it has direct cost implications at scale. Fendt 1000 Vario series, particularly the 1500, was engineered around a specific principle: deliver high power at low engine speed. The 1050 Vario produces approximately 500 horsepower from a 12.4-liter MAN engine. But the critical design feature is how that power is delivered. Fendt's ID system operates the engine primarily between 1,100 to 1,500 revolutions per minute, where specific fuel consumption reaches its lowest point. In DLG Power Mix standardized testing, a closely related 1042 Vario recorded approximately 235 grams per kilowatt-hour diesel consumption, with around 19 grams per kilowatt-hour AdBlue usage, among the lowest figures recorded in the test at that time. This efficiency translates directly to reduced fuel cost per hectare during extended field operations. With permissible field weight up to roughly 21 tons and the continuously variable Vario transmission, a 1500 can pull 12-meter cultivators or combination drills at 10 to 12 kilometers per hour, covering approximately 12 to 14 hectares per hour under favorable conditions with uninterrupted field blocks. Over a full working day, this translates to 100-plus hectares under efficient operation, a level of daily output that historically required two smaller tractors. On deep tillage, the 1050 handles 8 to 10 furrow reversible plows at 7 to 8 kilometers per hour, delivering high draft work at widths and speeds that eliminate the need for multiple tractor passes. The CVT automatically maintains optimal slip and load, protecting soil structure while minimizing fuel waste from excessive wheel spin. Engineering for low fuel consumption matters at scale, but some large European operations consistently choose a different machine based on a different calculation. Total cost per hectare when precision technology and uptime are factored in. The John Deere 8R410 appears frequently in high-output operations for reasons that become clear when examining actual field performance. Rated at 410 horsepower with up to approximately 458 horsepower available through intelligent power management, The 9.0-liter six-cylinder engine feeds either an E23 power shift or electric variable transmission. With the optional dual-pump hydraulic system, total flow can reach 318 liters per minute, sufficient to run high-demand air drills and large planters at consistent fan speeds, while simultaneously operating steering and hydraulic lift functions. In practical field operations, an 8R410 equipped with a 6-meter combination drill operating at 10 to 12 kilometers per hour can cover approximately 60 to 70 hectares per day during a 10-hour shift, assuming efficient headland management and minimal transport interruptions. On heavy cultivation work, the same tractor pulling 7 to 8 meter shallow cultivators can complete 50+ hectares per day, while maintaining specific fuel consumption in the 230 to 260 grams per kilowatt-hour range under mixed load cycles. However, the 8R410's operational advantage isn't purely mechanical. Integrated precision agriculture, automatic section control, RTK guidance, and comprehensive isobuse compatibility allows higher effective working speeds without overlap waste. This reduces liters per hectare even when liters per hour remain elevated, a distinction that directly impacts fuel cost at scale. The 14-ton base weight and long wheelbase provide high traction efficiency, particularly with dual rear tires. Under heavy draft loads, this translates to low slip percentages, converting engine power into tractive effort rather than wasted wheel spin. This matters most on heavier clay soils or during autumn cultivation when soil conditions are less than ideal. The 8R410 is not the least expensive option, not the highest horsepower tractor available, and not the lowest fuel consumer on a grams per kilowatt-hour basis. But it consistently delivers high hectares per day with competitive total cost per hectare when accounting for uptime, operator efficiency, precision technology integration, and resale value retention. These combined factors explain its frequent appearance on large European arable operations, where daily output and operating costs directly determine profitability. Most farms prioritize either daily output or fuel efficiency within conventional tractor designs, but some farm operations face constraints that conventional tractor design cannot efficiently address. Exceptionally heavy implements, extreme draft requirements, or transport loads that exceed what traditional chassis configurations can handle safely. In those situations, increasing horsepower within a standard tractor layout stops being an effective solution. The Class Zerion 5000 Track VC uses a reversed operator position and equal-sized wheels on both axles, allowing implement mounting at either end and theoretically better weight distribution under very heavy loads. Power comes from a Mercedes-Benz 6-cylinder engine delivering approximately 500 to 530 horsepower depending on configuration, with continuously variable transmission and hydraulic capacity supporting large, high-demand implements. The Zerion's design is most relevant for specific applications: wide combination drills requiring significant weight for penetration, heavy slurry tankers needing stable high-speed transport, or specialized tasks like municipal work where versatility matters more than pure field efficiency. The reversed cab position allows the operator to face the implement during work, useful for precision tasks but less relevant during straight-line field operations. In field work, the Zerion handles very wide implements, 12+ meter combinations or large tanker applications, though daily hectare output depends heavily on implement type and field conditions. Its weight and traction capabilities suit heavy clay soils or operations requiring aggressive soil engagement. Specialized chassis design solves niche problems, but Northern European farms face a broader constraint of needing genuine versatility across arable, livestock, and forestry work in climates with extended winter periods. Valtra's T-Series, particularly the T254 at approximately 250 to 270 horsepower, addresses this through design choices prioritizing adaptability. The AGCO power engine provides sufficient power for primary field operations while remaining efficient on lighter tasks. Twin-track reverse drive capability allows the operator to face either direction, useful during loader work, snow clearing, or forestry operations where implement visibility matters more than forward speed. In arable work, the T254 handles medium-width implements, 5 to 6 meter drills or cultivators, at speeds delivering approximately 4 to 6 hectares per hour under favorable conditions. On forestry-adjacent farm work, the tractor's chassis design and available power support, timber extraction, firewood processing, and heavy trailer work without requiring separate dedicated forestry equipment. The T-Series is frequently chosen by Northern European mixed farms where one tractor must reliably handle arable, livestock, and forestry tasks across variable seasonal conditions. These 12 tractors represent different engineering priorities such as fuel efficiency, daily output, transport logistics, operator comfort, or multitask versatility. None is universally superior. Each addresses specific operational constraints under real European farming conditions. If this breakdown helped you understand how tractors are actually chosen on European production farms, subscribe to our channel for future content focused on real production equipment and engineering trade-offs. We focus on real field performance, measurable output, and engineering trade-offs, not rankings, hype, or brochure claims.